So we're going to continue with 1.4 here. You've already started your Germ Guide app. I'm going to have you go back to that Germ Guide app after this lesson and have you finish it up by adding some more things to it. But first, we're going to go through this lesson on PLTW. So if you want to stop and open this up, your PLTW account, my.pltw.org, and go to 1.4, you can. Otherwise, just kind of follow along today. We're going to talk about coding with conditions, which is adding a little bit to our idea of how to make flowcharts with conditional flowcharting. So remember, this is a handout that I've given to you guys. We worked on linear flowcharts in 1.2. Today we're going to talk about conditional flowcharts, which are here. Okay, this is the thing we're going to talk about, conditional flowcharting, which is what's more realistic when you have scenarios that pop up that make you have to do one thing or the other. So when approaching a street intersection with a traffic light, a driver has to make sure the light is green before crossing. So if it's red, the driver has to stop. If it's yellow, they have to go real fast to get ahead of it. Just kidding. The thought process that drivers follow in an intersection is very similar to the process computers use to make decisions. Remember, we make flowcharts because the computers can't think for themselves. So computers are able to respond to what we provide as events for the computer to think about. We can give them answers like yes or no, or true, false. Questions in the code, that's really what we're discussing. So these questions are actions that a computer could take based on the answers. We call those conditional statements. When we give them a true, false, or yes, no statement, that's called Boolean logic. So in this activity, we're going to learn about how we can write down these conditional statements. So can you think of any yes or no questions that you can make as a statement in everyday life? Should I cross the street? Yes or no. Should I follow this video? Yes or no. Should I get up in the morning? Yes or no. Should I brush my teeth? There's a lot of different things you can think about. We're going to watch this video to talk about conditional flowcharts. Again, I'm going to put the captions on. And if you struggle for watching this, I did put the video on here. The quality is a little better than ours, but it is there in case you want to watch it again.
This video explores algorithms with conditions or conditional statements. We remember that linear algorithms are a set of directions that flow from one step to another. Let's review the example of planning a birthday party. Looking at this flowchart, it's easy to see why this type of algorithm is called linear. The steps in the algorithm flow in a straight line. But what if you need to make a decision before you can complete a step? For example, what if it's raining on the day of the party and you have to move the party location? Could you create instructions that include a backup plan? To create an algorithm that includes decisions, you add conditional statements to the algorithm. Conditional statements are questions that check whether a condition is true and then perform one action if it's true and a different action if it's false. An example condition could be, is it raining outside? The answer is either yes or no. In this case, the answer would be no, and you proceed to the next step. Just like linear algorithms, algorithms with conditional statements can be shown in a flowchart. Let's look again at the birthday party flowchart and add our conditional statement about rain. In order to determine whether the party should be inside or outside, the condition to check is whether or not it's raining. If the answer is yes, it's raining, then you should have the party inside. If the answer is no, it's not raining, then you can have the party outside. So how do we represent this condition in the flowchart? In a flowchart, the rhombus, or diamond-shaped component, is used to indicate that a decision has to be made. The rhombus should always contain a yes, no, or true-false question. So after purchasing party decorations, you come to your conditional statement. Is it raining outside? Yes? Then set up the party inside. No? Then set up the party outside. Computer scientists create sophisticated programs that can carry out complex algorithms. A lot of these algorithms contain conditional logic to complete their tasks properly. Here's an example. A vending machine uses a conditional statement before it dispenses a snack. It checks to see whether you entered a valid code. If yes, then it dispenses the snack. If no, it displays an error on its screen. Can you think of other conditions the vending machine might need to check for? How about money? The vending machine needs to be programmed to check whether you've inserted enough money before it dispenses the snack. Now that you've learned about algorithms with conditions, you're ready to start creating them.
Got really loud there at the end. I don't know why. All right. So algorithms that contain conditions, we also call these conditional algorithms. They can be written using a number of listed representative flowchart and so on. So we did this last time. Ovals begin and end it. Rectangles are the actions. Arrows move to the next step. Now we have a rhombus. These are our true, false, yes, no statements. Let's take a look at an example. Here is kind of looking at if it's raining again. So begin, end, ovals. Now, you're either going to walk to school or you're going to ride the bus. But to determine the yes or the no statement, we have to see, is it raining? If it's raining and we say, yes, it is raining, then you ride the bus. No, you walk to school. This is an example of a conditional statement. The conditional question being asked here is it's raining? If it is raining, ride the bus. If it isn't raining, walk to school. That's how you do a conditional statement. That's really all the addition is. But now we're going to look at the field trip again. And one of the things we're going to think about is this stuff that people used to think was science fiction. Now it's real, is autonomous vehicles. Automobiles that can operate without a driver. I wish I had one of those, and maybe one day I'll finally get that cool Tesla I've always wanted. But for now, I'm okay with what I got. Just doesn't autonomously drive. So for autonomous vehicles that drive without a human, they need to be able to think about the environment around them. They're constantly going through these conditional statements. So computer scientists write highly complex algorithms that include a lot of different conditional logic for the computer to think through. So in this task, you're going to write a simple algorithm to navigate the autonomous bus from anywhere on this map to the museum. So the bus just needs to get from wherever it is. So it could be here at the school. We could say the bus is up here by the stop sign. We could say the bus is over here. In any situation, the bus needs to know what to do to get to the museum. Okay? Now, same rules apply as in 1.2. Move forward. We have a new one, wait 5 seconds, and then turn left and turn right. The other difference is move forward just simply means the bus can move. Let me pull this version up so we can look at it. And when I say the bus can move wherever it wants, let me bring our bus back here. When we say it can move, so if we say move forward, remember in 1.2, move forward meant here. Or move forward meant here. Now, when we say move forward, it could mean this. Okay? It also can mean this, which is a little tricky, but remember, move forward just means the bus can move. Oops, I double-clicked Apple products. Move forward means it could go like this. Oh, I did it again. Should get my mouse out. Move forward can go around a corner and around a corner. Okay? Move forward just means it can move. Okay? The only time it needs to worry about the turn left or the turn right is if there's a sign in the way, where if a sign was here, that would mean you can't turn right. So it would have to, at this point, say turn left. Okay? So really what we're doing is we're writing a flowchart now that's going to allow our map or our bus to think about how to read these signs. It has to get a bunch of practice at it. It basically has to be able to read that every time it sees this, it means don't turn left, don't turn left, don't turn left. Now that we have our program written, we're going to do that. Okay, so I'm going to write with you a conditional flowchart of how this works. Okay, so the bus can be anywhere. Remember, the first thing we have to start thinking about here are 3 questions. Okay, I'm going to move this a little bit. There's 4 questions we need to think about. First one is one that we've probably all said when we're driving somewhere to our parents, and that's, are we there yet? Okay, so are we there yet? Now remember, there's either the yes statement or the no statement. So if we were on the bus and we said, "Are we there yet?" that would mean that we're here at the museum. So what happens there? Well, only one thing happens when they're at the museum. I'm even going to put down the symbol there. That means in the flowchart, we're done. Okay? If we're not there yet, which statement would we use down here? If you said move forward, that's correct. Because if we're not there, we just have to keep moving forward. Move forward. Okay? The next question we have to say is, can I turn left? Okay, you can be writing this down too, or you can just follow along, and then you're going to have one thing you're going to have to complete. Can I turn left? If I can turn left, then there's no reason I have to worry about turning right or anything. So here it just means move forward. Okay. If no, that means that I am going to have to turn right. So again, if you can't turn left, then you have to turn right. So what I'm going to do now is I'm going to do the next one, which is actually pretty similar to the question I just asked, which is, can I turn left? My other question that's very similar to that would be, can I turn right? Can I turn right? So if I can turn right, what do I continue to do? Just like the last one, move forward. And if no, I'm going to turn left. Okay, those are our three questions. The last question we need to ask ourselves, if we think back to the signs here, we've covered a no turn left sign, we've covered a no turn right sign. The one sign we haven't covered yet is the stop sign. So that would be the next question that we need to ask. So number 4 is, do I need to stop? Okay. If we need to stop, what command do we need here? Take a look at the commands. What command do we need here if we need to stop? All right. If you said wait 5 seconds, that is correct. So if I need to stop, the car or the bus will wait 5 seconds. And if no, like everything else, move forward. Okay? So just like everything else, we would just continue to move forward. That's how that's going to work. All right. So if I'm going to have to write a flow chart for this, I'm going to try to keep things pretty simple as long as I get the bus to think about this flow chart using these conditional statements. So all 4 of these conditional statements are going to show up in our flow chart. Well, what are we going to start with? Flow chart should always start with begin as our oval. Okay. So the first conditional statement we discussed was, are we there yet? So I'm going to put that as a conditional statement. So that's going to be a rhombus. Are we there yet? Okay. So every one of these, we're always going to be consistent. Yes is going to go to the right. No is going to go down. So as we said in our statement to the left here, are we there yet? If yes, that's the end. So if our bus was sitting in the parking lot, that would be all we need. If no, move forward. So we're going to put that box in here. Move forward. Okay? Now, the next question, I'm actually going to jump down here so I can get out of the way in case we lose it, because it really doesn't matter what order we have these. As long as our bus starts to memorize, if it sees this sign, it knows what to do. If it sees this sign, it knows what to do. If it sees this sign, it knows what to do. And it just knows to get to the museum. So the next question I'm going to say is there a stop sign or do I need to stop? So another, do I need to stop? Okay. And if yes, and that doesn't mean doing the video, it means the bus. So don't try to stop me here. If I need to stop, and yes, the command we had was wait 5 seconds. Okay. So wait 5 seconds. If no, well, then we just keep moving forward. Well, since we already know we're always going to keep moving forward, we can get it to start thinking about the other signs right away. So let's get it to think about all the other signs as we go here, and then we'll talk about how you can connect these all. Because remember, the ultimate goal is we always want everything to go back to the end. You always want it to go from beginning to end, and we're going to connect these. Okay, so the next thing we had was, so if it's a no, let's go to the next question. And then let me just change my angle of my camera there. The next two questions were, can I turn left? And then the other one was, can I turn right? Can I turn right? I'll put the yeses there. So if I can turn left and if I can turn right, okay, then what I'm going to do is I'm simply just going to either move forward or turn left or turn right. So if I can turn left, all we need to do is tell the thing then go ahead and turn left. If I can turn right, well then, bus, turn right. Okay. If not, it's going to have to do the opposite. Okay. So these are just the same as saying move forward, but they're just the opposite. So if all these things are going to then have us to, the bus has to constantly think about these steps the entire time, then what do? Well, what we want to do is we want to be able to have these all kind of connect together. So if I put these all three together and I put another line down here, okay, all of these are going to go to the same spot. If it's a no statement, then that means that we have to bring our line all the way back up to the are we there yet? And why is that? Well, this may be a little confusing for you, but the reason is because if it waits 5 seconds, now it has to move forward. Well, if that's the case, bring it around and have it ask the question again. Well, before I start moving the bus, are we there yet? Right? It may stop because it's in the parking lot. So here it has to ask, are we there yet? If it is, then we end. If not, you move forward and you ask the next question. Can I turn left? Well, if yes, you could turn left. What do we do after we turn left? We move back to move forward. Can I turn right? Well, yes, you can turn right. What do? I move forward. So these are all the opposites. So this is how you would create your flow chart for the bus. Are we there yet or are we not? So again, hopefully you've paused. You can rewind back and see certain things you need to copy down to have this. Now, why would you want to have this written down? Well, because the last thing I'm going to have you do in today's lesson is we're going to scroll down here to the conclusion question. So you're going to have to complete this. I'll have a Google form that you can fill out on Google Classroom. But a car has to travel over railroad tracks to get to the park. Write a simple algorithm that includes a conditional statement for the driver. I want you to give it a shot. Okay. You may be way off, may not. I'll give you feedback if you're way off. Okay, I just want you to try these things. So go ahead and complete your own flowchart, and you're going to have to submit that to me on Google Classroom. So through a Google form. So again, that means you could take a picture of your notebook like this, or you can do something on digitally like Draw.io or Google Drawings or something like that. It doesn't matter. but your goal is to answer this question, get it into me. And that's it for this lesson. All right, we'll see you next time.